Good evening and welcome to the April Astro Talk for the ASV. This month we're going to hear from Duane Hamacher. Duane is an Associate Professor of Cultural Astronomy at the School of Physics at University of Melbourne, and tonight Duane will be talking to us about how we can all learn from Indigenous astronomy in the world of astrophysics. Following Duane's talk, we're going to hear from AI, Artificial Intelligent Bill Stent, the telescope gent, because he's got COVID, which means you have to put up with me giving the tour of what's in the sky for April and May of 2025. Before we begin tonight's talk, just a couple of housekeeping items. We have the Mildura Star Party coming up on the Anzac Day long weekend up at Mildura. And we also have for ASV members, the Marangurk Star Party at the end of May as well. So members, you'll find the links for the Marangurk Star Party in the members side and also in Crux Extra. And for those of you who are not members, Mildura Star Party, great opportunity to get away from Melbourne for the long weekend and visit part of regional Victoria and enjoy some wonderful dark skies. For now, we're going to bring in Duane so he can present his talk. Duane, good evening. How you going?
Good evening. Thanks, Mark. I appreciate it. Everything working?
It is. We're ready to rock. So I'm going to hand straight over to you, Duane, and you can take it away. I'll pull myself back into the green room and the floor is yours.
Thanks a lot. Thanks, Mark. I appreciate it. And I appreciate the ASV inviting me to come and give this talk on how Indigenous star knowledge can guide modern astrophysics. Very controversial talk we're talking about tonight. I have been working in the space of Indigenous astronomy for about 16 years. I studied physics for my degree back in the US and came to Australia for the first time 22 years ago. And that set me on this curious pathway to where I am now. And over the years, I earned a master's degree in astrophysics, searching for exoplanets. And then I transferred my interests over to the world of Indigenous astronomy. And since doing my PhD in Indigenous astronomy, I have been focusing on unpacking the layers of scientific information encoded within these knowledges. So this is an interesting topic that I began doing because I heard a lot of Australians, a lot of people saying, Aboriginal people have no scientific knowledge. They have no capacity for any of that. There's simply some myths and legends and stories about stuff, but there's certainly no science there. Stupid seppos, what do you know? That kind of attitude. And with the eyes of an astronomer and with the background in physics, it's not difficult at all to see how much science is encoded, is embedded, and is shared within these knowledge systems and then passed down through various cultural traditions. We're going to unpack a little bit of that today, but what I want to focus on is how Indigenous star knowledge can actually guide modern astrophysics. And I think in this context, it's important to clarify this is something that the larger astrophysics community in Australia and around the world is very much taking on board. We just submitted a major center of excellence on an area of astronomy that's directly involving this. An Indigenous theme is a major component of that, including the research program. Not simply, outreach and education, which I love, but also the actual research side of this, how Indigenous star knowledge can guide modern astrophysics and how astrophysicists and elders can work together to not only better the culture of doing astrophysics, but to better understand our place in the universe and actually guide astrophysical practices themselves. So keeping this in mind, this is something that the wider astrophysics community is a part of, is involved with this and is supportive of this. And I can assure you that if I were prancing around teaching airy-fairy astrology and stuff, they would not be supporting this. And that is not the case. So I think to give some context, this actually first part ties into a talk I gave a few years ago at the ASV, and I think it's worth reiterating that there are a few major themes that come across in this research, and it's important to understand the context of Indigenous astronomy or Indigenous star knowledge and the Indigenous traditions through which it is passed down. So I want to start off by saying there is a difference between Indigenous astronomy and Indigenous star knowledge. And there is a difference between knowledge and traditions. So let's unpack that before we get into the stuff I'm talking about here on the screen. When we talk about sky knowledge, we talk about the cultural knowledge developed by Aboriginal and Torres Strait Islander people, and most any culture around the world, that's going to relate to things happening in the sky. Now, that isn't purely just celestial stuff. That can be weather and climate, clouds and things of that nature, meteorology, that kind of stuff happening as well. But it's part of what people here refer to as sky country. So people refer to the land on which they live, their local environment, as country. You can have land country, you can have sea country, and of course you have sky country. And that's all a system that is embedded within each other. No part of that can really be separated. And that's something that ties into what I'm going to talk about in a second. But it's really important to say there's that wider body of knowledge. There's also the more specific body of knowledge that ties into the actual knowledge and understanding of the stars, what we might think of as scientific understanding. That is Indigenous astronomy, right? And I also use a little bit of a double entendre when I talk about Indigenous astronomy. It is the astronomy of Indigenous people, but it is also the Indigenous astronomy, the astronomy that was around before the term astronomy ever existed. And for those who may wonder, well, did traditional people practice astronomy? Yes, absolutely. And there are names for those people who practice astronomy. I talk about in the Torres Strait, where I do a lot of the research that I do with communities. There they call the astronomer the Zugabal Mabaig. The Zugabal refer to the spiritual ancestors who became stars and constellations. And Mabaig is simply a Kalulagoya term for a man or a person. So it literally means star man or constellation man, constellation person, who goes through a number of years of rigorous training, starting off in their mid-teens, in the art and the science of astronomy and star knowledge, and continues that training throughout their adulthood. So I think it's important to give some context. When we throw these terms around, they all have a specific meaning, right? So Indigenous astronomy and Indigenous sky knowledge are distinct, but of course there's a huge layover because one comes from the other. But knowledge is the understanding we have about how things work in our world, whether we're looking up at the sky or looking down on the land. And the traditions are the ways in which that knowledge is practiced and or in which that knowledge is passed down to successive generations. So tying in with what I'm showing you on the screen here, the person on the far left is Professor Annette Lee. Annette Lee is a Lakota, Dakota woman from Minneapolis. She's a professional artist with 2 MFAs and a BFA, Bachelor and Master of Fine Arts. She's also got a bachelor's, master's, and PhD in astrophysics, and she's got a doctor of science. And she is the director of Native Skywatchers, a professional organization dedicated to Indigenous astronomy there in North America. And she, like every other elder I've ever learned from, say the same thing. Everything on the land is reflected in the sky. As is above, so is below. If you want to understand how things in the world around you work, you look to the stars. The stars serve as a map, as a directional aid, as a timepiece, as a clock. Stars serve as a mnemonic, as a memory space, as a canvas, storyboard on which you can, paint your stories and your art, your narratives, in which knowledge is encoded that you pass on to successive generations. If you want to understand animal behavior, you look to the stars. If you want to understand the plants and medicine, you look to the stars. If you want to see how the landscape is laid out, you can map that out in the stars. The stars inform everything that happens down here in our terrestrial world. In the middle here, we have an image of Professor Martin Nakata. He's the first Torres Strait Islander to earn a PhD. He's currently the Deputy Vice Chancellor at JCU up in Townsville. And he, said when he was young, he came to a crossroads in his life. He couldn't figure out if he wanted to pursue his degrees in education or in astrophysics. He chose education. He says he doesn't really regret it, but he always had that very keen interest in astronomy. And now we have been working together for well over a decade, to build up the space of Indigenous astronomy. He's the academic who gave me my very first job when I came out of my PhD. And one of the things that he sat and taught me, which frankly I kind of already knew, but he reshared this, is that we're a people of culture. Nobody really argues with that. But we're also a people of science. And this is something that some people just can't seem to wrap their head around, that there are people that understand how the world around them works. They understand that world around them through observation, through inductive and deductive reasoning, through experimentation, through trial by error. You have to figure out how things work and how to develop systems, how these things are interlinked together and how they relate together. And if your information is wrong, it's not just that you're wrong, it's that you could potentially die. If your community, food, navigation, whatever it happens to be, you're developing knowledge based on the world around you, and you get that information wrong, it's not a minor infraction, right? So in this context, he talks about we are a people of science. Now, I think it's important to mention that the world of what we think of as Western science that came out in the scientific revolution, we think of Copernicus and Galileo and Newton up through Einstein. We think of that body of knowledge, a larger body of scientific knowledge, and indigenous knowledges, right, plural, because every indigenous culture is going to have their own knowledge, their own ontologies, their own ways of understanding the world. When you look at them, they're not the exact same thing. You can't put an equal sign between them. They're two different systems of knowledge, well, multiple systems, but they're different systems of knowledge about understanding the world in which we live that are asking different questions, and they have different applications, right? But there is a crossover. If you were to see a Venn diagram, the Venn diagram is not going to be a perfect circle, but it's not going to be two separate circles, right? There is a crossover. There are ways in which those worlds interlink very closely together. That is the world in which I primarily work. And that is the world in which I'm going to be talking to you about tonight. So I think it's important to lay that out. When we talk about indigenous science, we're not equating it to Western science. We're showing there are ways of understanding the world around us, that they have similar foundational practices, and that they can inform each other in a lot of different ways. On the right here, we have a picture of Uncle Alo Tapim. He's one of the senior elders on the island of Mare in the far east of the Torres Strait. This is the island that Edikweki Mabo was from. I'm sure you'd be familiar with Mabo Day, and his court case that overturned Terra Nullius. He talks about how your ability to thrive in your environment depends on your ability to read your environment. In this case, read the stars. So to be able to observe and interpret what you see in the sky and find meaning in that. So if you want to observe the changes in the properties and the positions of the stars, you can find a lot of important information out of that if you understand how to read it. So we're going to talk a little bit about today, how science is embedded within indigenous knowledge, but with the focus on how this can actually guide scientific practice. And one of the first things that's critically important that we understand is getting away from this idea that the two opposite ends in the spectrum are fact and myth. Myth is not the opposite of fact, right? I used to hate using the term myth or mythology because of all the negative connotations. And now I'm like, you know what? Screw it. We're taking it back. Myth means story. Okay. Mythology is the study of spoken stories. Myth is a mnemonic. Mythology is the way that we pass down information over time. And most cultures in human history have done this. The idea of structured written languages is a fairly recent invention in human history. I'm using history in the broad sense, not purely in the written record sense. But when we talk about mythology, mythology was meant to convey multiple layers of information, multiple layers of knowledge in a way that could be passed down to successive generations while maintaining vitality. So these stories have a lot of different layers of meaning that are embedded within them. There's going to be some scientific layers of information if you know how to unpack them. There's also going to be social lessons in there. There's going to be fables. There's going to be allegory, right? But the idea that, if you go back to, some arguments that, might be saying, oh, well, you're teaching myth as science. Teaching myth as science makes no sense because myth isn't the opposite of science. Myth is a mode of knowledge transmission. It's like saying you shouldn't teach a book as science. That doesn't make any sense. You can't teach a book as science. There's information in the book that can teach you about science or cannot teach you about science. Myth is the same way. Oral tradition, being the more preferred term that we use, is about how you can encode that knowledge in and pass it down. And that can include song and dance and art and a lot of other things. But the first thing you have to do is unpack what myth means and really understand the power of orality. And that when you hear about oral traditions, that doesn't mean they're just made up little stories. That is knowledge being passed on orally, and it's extremely powerful. And if you want to learn more about that, I highly recommend reading the books of Lynn Kelly, books like Memory Space, The Memory Code, and her new book, The Knowledge Gene, which unpacks the actual genetic foundation of how we as humans have the capacity to do that. So I want to get right into some of the fun examples of this. So when we're looking at certain areas of astrophysics, there are going to be areas in which indigenous knowledges are going to be able to inform them quite well, and there are going to be areas where they're not. That's just fine. Same goes, there are ways that astrophysics could help inform indigenous knowledges and ways in which it couldn't. But let's start to unpack some of the ways in which they can. So part of the research that I'm doing is on transient astronomy. So these are, everybody knows what transients are, short-term kinds of events. There can be a lot of different types of transient events, whether it's a comet or a meteor or even aurora. But in the terms of astrophysics, we're talking more about cosmic explosions. But you can have non-explosive things as well, like variable stars. Now, there are different types of variable stars. Stars that change in brightness over time are called variable stars. And there's two primary types. You have intrinsic and extrinsic. Intrinsic variable stars is something within the physical structure of the star that's going to cause it to change brightness over time. And extrinsic is something outside the physical star itself that's going to cause it to change brightness. So with intrinsic, we have the pulsating stars, where the stars literally themselves pulsate. You got your Cepheid, your R Lyra, your RV Tauri, these long-term variables like your Mira. You've got all those you can go into. You've also got your eruptive or cataclysmic stars. These are things like your supernova and your nova, your supernova imposters, your current nova. These are things, it's something about the star, but it's not like a regular pulsation. It's more eruptive, more cataclysmic. The extrinsic types of stars are when something is happening outside the structure of the star itself that's making its light change. And in general, there's two types. Rotating variables are basically stars with giant sunspots on them. And as they rotate, the side that has the sunspots is not going to be giving off as much light. The other type are eclipsing binaries. And these are when you get the two stars. These are when you get the two stars moving in front of each other or behind each other. This is the stuff that I studied when I was doing my degree in astrophysics, what became my master's degree on transiting exoplanets. As one small star moves in front of the big one, it dips the overall light curve of that. So we've got examples of these within cultural traditions of the world. And what I want to do is talk about how looking back at both written and oral cultural traditions from cultures around the world can help guide modern astrophysical practices. So in that context, astrophysicists, we have our eyes to the skies. We're doing lots of large-scale surveys using survey telescopes, and we're picking up all kinds of transient events. We have to go through, catalog them, analyze them, sort them, and figure out what's interesting, what's not. And a lot of things are quite interesting in that regard. So there are going to be lots of variable stars of different types. And I want to talk to you about some oral traditions that describe stellar variability with a focus on here in Australia. So one of these stories comes from the Coorong, the area down south of Adelaide. The Nurrinjeri people there's a number of different narratives that talk about this man called Wayangari. Wayangari literally means the red man. And this is an initiate. So the story was there was an initiate, mid-teens, who was going through his initiation phase. And part of that is that he had to prove himself both intellectually and physically. The physical aspect of this meant that he had to go for about a week or so on his own, out away from the community, away from everybody else, and prove himself. He wasn't allowed to wear any clothing. He had to fast the whole time. He wasn't allowed to have contact with anybody else. But the whole time, he was covered from head to foot in red ochre, hence the name Waiangari. Now, there are different narratives of this story depending on the communities, but some of the communities talk about how Waiangari one day was drinking water through a reed as a straw, and as he bent down to drink water near this river, some of the ochre fell off into the water and washed down shore. And down shore, two women saw the ochre in the water, and they were wondering where it came from. And they sort of snuck around, and they saw Waiangari, and they thought that he was quite attractive. They followed Waiangari as he went back into his own little hut that he had built. And when he had gone in to sleep for the night, they morphed into emus and created sounds of emus, which, being the hunter he is, drove him outside. And when he came out to try to, spear the emus, they morphed back into beautiful women, threw their arms around him, and said they wanted to be his wives. And they went into the hut, and we'll let you draw your own conclusions about what happened there. Now, in the narrative, these two women were actually his sisters-in-law. They were the wives of his brother, Nepali. Now, this might seem a little strange to some people. How come he wouldn't recognize his sisters-in-laws? When you reach a particular age in a lot of Aboriginal cultures, certain parts of your family become taboo to you. You're not allowed to associate or link with them. That often happens between mother-in-laws and son-in-laws, and it also happens across sort of, siblings with in-laws. Now, news of this got to his brother Nepali, and Nepali became very angry about this, flew into a fit of rage, and tried to set the hut on fire that they were in. They woke up in time, running outside, realizing that they were facing death as a consequence. They began running down the river and decided their best chance of escaping death was to go into the sky. So Waiangari casts a spear into the Milky Way, pulls himself and the two women up, and he pulls his canoe behind him. He becomes a bright red star in the Milky Way. The two women become these whiter stars flanking him on either side. And he pulls his canoe up into the sky, which can be traced out as a beautiful constellation, with the celestial emu off to the east. And as these stars rise and set throughout the year, they indicate changing seasons and the behavior of plants and animals. Now, when this particular group of stars is high in the sky just after sunset, when it's culminating, when it's sort of crossing the meridian, highest point in the sky after sunset, this signifies that they're starting to come out of the depths of winter. They're coming into what we think of as spring, and there's a rejuvenation in the air. This means that the animals are coming into season, and the traditions talk about how Waiangari in his celestial canoe can be seen sometimes getting hotter and brighter. And he's sort of getting hotter and brighter over time, and that later on, that will fade again. But when it gets hotter and brighter, it's signifying to the people that his passions are on the increase, and it's meant to be a taboo relation story to people, that they recognize that, and it reminds them about the traditions and the taboo he broke, and to control themselves and do the right thing. So there's a moral narrative. There's a whole lot more to that story. I'm just giving the bare bones version of it. Now, early anthropologists, when they began looking at this story, because most anthropologists don't know much about astronomy, fair enough, they misidentified the star in question. And they said, it must be the planet Mars. It's bright and red, must be Mars, right? And for a long time, they couldn't quite figure out who the two women were. And they even went to an astronomer and said that this story is talking about Mars. Who were the two women? And the astronomer, the government astronomer, Dodwell, said, well, maybe there are two planets coming into conjunction every once in a while, like Venus and Jupiter or something. And he didn't really know. And it wasn't until probably about 2018, I think it was, that an anthropologist colleague of mine sent me a paper he had written pulling all these stories of Waiangari together, and he wanted my opinion. He said, I don't think that this makes any sense. I don't think that this is Mars. What do you think? And I started going through the stories and looking it up and studying, and it was obvious what it was. I think most everybody in the room or watching would know who it is. What's a bright curve of stars high in the Milky Way, around August and September, sort of coming out of winter with the Emu off to the east, a bright red star flanked by two other white stars. It's the star Antares. And Tau and Sigma Scorpii are the two wives, and Scorpius is the canoe. You find this all across the Pacific and even Australia. It's a very common motif to see that described in that way. So what's interesting is they're talking about this star changing in brightness over time, right? They thought it was Mars. It's not Mars. It's the star Antares. But Antares itself is a variable star, and it changes by well over a magnitude over the course of about 3.5 years. So there seem to be traditions talking about this star changing in brightness over time. Now, it can be a challenge to observe variable stars, as I think most of you would recognize. But there's some things to consider. Firstly, if you're going to notice stars changing in brightness over time, you need to have some comparative stars around by which you can judge changes in brightness. A star off on its own, like say Canopus, for example, might be a bit of a challenge. There aren't a lot of bright stars around Canopus in the sky. But if you look at something like Antares, there's lots of bright stars around through which you can tell whether the star is getting brighter or fainter. And it can change by well over a magnitude over the course of a few years, something that you'd be able to notice if you keep close attention to the skies. There is another tradition that's part of the Seven Sister songline that goes from coast to coast across Australia. It talks about Wati Niru, some places Nairuna. It's the man in Orion who is in constant pursuit of the sisters of the Pleiades. Now, there are a lot of early colonial records that talk about this figure in the sky, whether it's in the Central Desert, whether it's over in New South Wales, whether it's in WA, talk about this group of stars representing a man, Orion, in the same orientation as his Greek counterpart. What that means is the traditions specifically say, many of them, that he's upside down in the sky. Even early Daisy Bates talked about how curious that was. They would describe him as being upside down in the sky. And we think of certain parts of Orion, like his scabbard. The scabbard of Orion was not described as a scabbard until about the Victorian era. It was described as something it kind of looks like to most of you if you look up and see a man up in the stars. And that's exactly how the Aboriginal communities would talk about that. So the story is that he would be chasing these young girls, the Pleiades. They didn't want to have anything to do with him, but he wanted to make the youngest girl one of his wives. Their elder sister got sick and tired of his behavior, and she's represented by the stars in the Hyades, that V shape of stars. And she would continually draw attention away from her sisters and to herself and mock Nairuna. And she would, taunt him and just do whatever she could to get his attention away from her. And this would anger him to the point where he would create fire magic in his right hand, the red star Betelgeuse. And he would try to cast fire magic at her to get her out of the way. Well, she wasn't taking his crap. She would create fire magic in her left foot, which is the star Aldebaran. And she would kick sand back at him. She would kick this fire magic back at him, which would humiliate him, and his fire magic would die down again. And this cycle keeps happening. He would come back again brighter, but this next time, she called on Baba, the father dingo, who came in and started shaking Orion, while the other stars around twinkled in laughter and humiliation at Nairuna. It was stories about appropriate behaviors, story about what it's okay to do and what's not okay to do. And there are lots of stories that are embedded within the landscape all the way across the country with the songline, literally a navigational map across the country that's encoded in song that tells you where everything on the land is that's mapped out as a reflection in the sky. But if you look at the scientific elements of this, you've got the diurnal motion of Wayangari chasing these girls across the sky. You've got the bright group of stars between him and the young girls forcing away. You've also got this idea of the fire magic using the two red stars. Now, Only about 3 to 4% of visible stars in the sky are noticeably red. They're quite rare, as stars are, and those tend to have more special significance within indigenous cultural traditions. So they seem to be describing a variability of not only Betelgeuse, but of Aldebaran. Now, Betelgeuse changes by over a magnitude over the course of about 400 days. There's a couple of different cycles within its variability, but the primary one over a full magnitude takes course a bit over a year, about 13 months or so. And again, lots of comparative stars around by which you'd be able to notice that. But it also suggests that you are going to have Aldebaran also changing brightness over time. Now, our light curve data of Aldebaran is quite incomplete, and it doesn't go back a very long ways. There are periodic changes in the brightness of Aldebaran that, well, I shouldn't say periodic. They're definitely, if anything, semi-periodic, but they're almost kind of somewhat random, where it'll go through a bit of a change in brightness by a few tenths of a magnitude. The minimum you need to be able to see is about 2/10 of a magnitude. It can sometimes be a bit more than that. But if you look back on that, it indicates to us that perhaps, we don't know, but perhaps Aldebaran has a strange kind of behavior, that there could be more to its variability than our relatively short time periods of scientific data can tell us. That maybe there's some long-term variability, maybe there was some more variation in the past we don't know about today, but it brings up a topic that's worthy of investigation. Of course, when I brought this research up, there were some people who said this is rubbish. People can't observe the variability of Betelgeuse, whatever. But, in 2019 and 2020, Betelgeuse demonstrated for us a kind of rare form of variability. It wasn't its periodic form, but we went through the great dimming of Betelgeuse, where it became noticeably fainter. I think everybody would have been able to go outside and see how much fainter it was if you'd taken time to go out and see it. It's pretty amazing. So here's just some light curves of Antares, Betelgeuse, and Aldebaran to show their variability changes over time. So there's ways we can look at these stories, and that can inform us about stellar variability that we might not normally be looking at. I mean, nowadays, we've got lots of telescopes observing stars all the time, and we're finding all kinds of variable stars. My exoplanet research, there's tons of them out there. That just becomes mundane after a while, to tell you the truth. But there's always some interesting ones there. And I think that further investigation of Aldebaran could be a really great way of understanding that. Now, we can look at classic examples of stars like Algol, the blinking eye, or the winking eye of Medusa, and the constellation Perseus. Back in 1783, John Goodrick had sort of figured out that there's something strange happening with this system. It's a transiting binary system, and when the smallest star moves in front of the larger star, the smallest star moves behind the larger star, it drops the brightness quite a bit. Sorry, it's the little star when it moves in front, dims it. But anyway, it caused the brightness to change quite noticeably. And that can happen over several magnitudes. In some cases, Algol dips just a little bit by a bit over magnitude. I forget the exact amount it is, some relatively small amount, but it comes back up over a period of just a few hours. So if you're paying careful attention, you notice this. And in ancient Egyptian records, historians had managed to find records of this describing it. But curiously enough, there were multiple descriptions of this star winking over time. And when scientists went back and looked at these ancient records, they found a particular pattern in when this was happening. And doing a basic kind of Fourier analysis of this, they were able to recognize something quite exciting, that they were actually able to time the transits of Algol and realize that longer ago, they were occurring more quickly than they are now. Now, the scientific data shows that these two stars are actually moving away from each other. And this was one aspect of this sort of interdisciplinary research between ancient history and modern astrophysics in the world of cultural astronomy, where you can actually show that ancient records of these stars show nowadays that these stars are moving apart. We can see the change in that over time. That helps constrain physical models of these systems. So there's interesting ways in which both written and oral traditions can help guide modern astrophysical practices. So those are some examples of variable stars as far as the intrinsic pulsating types, or even the extrinsic eclipsing types. What about the cataclysmic types? And this ties in a little bit more to the stuff that we're doing in the world of transient astronomy right now. A somewhat well-known example of this was a paper that I published back in 2010 with a colleague named David Frew at Macquarie. He was an astronomer. And we went back and looked at these old traditions that were recorded from the Burong people, Burong meaning night, from up near Lake Tyrrell, where you had the Lake Tyrrell Star Party. Interesting fact, a lot of people know that Tyrrell means space, sky, stars, right? Because you can see the stars reflected in the lake. The Burong people prided themselves on being the best astronomers around. They prided themselves on their astronomical prowess and ability. Burong means darkness. They were the nighttime, the darkness people, and darkness in the context of nighttime. They had shared information with William Stambridge over a few years, and he wrote a 4 or 5-page paper in 1857 that gave just kind of a laundry list of stars, what their little description was and what their counterpart was. But one in particular line in that, he talks about Wa, the male crow, Wa being the onomatopoeia for the sound a crow makes, being the star Canopus, being the brother of Warpil, the eagle, and was the first down to bring, fire from Tyrrell, space, and gave it to the Aboriginal people. But also talks about Kalagolork Wa, which Kalagolork basically meant the wife of. Describes a large red star in Verbal Carol, marked 966, was the wife of Wa. All the small stars around her are her children. And we decided to research this and unpack this. Both of us worked in variable star astronomy, and as we began unpacking this, it was very clear what was being talked about. We had some descriptions of this. It was large, so bright is what they meant, red in color, in the now defunct constellation of Robert Carroll, which is now part of, Vela and Carina, that area, marked 966, so a catalog number. Now, back in the 1800s, there were not a whole lot of different astronomy catalogs like we have nowadays, right? And described it as being a bright star that seemed to be surrounded by a bunch of fainter stars, smaller stars, right? So when you start looking at what he's talking about, he's referring to these stars in the constantly, Robert Carroll became defunct, that it became Argus, and starts looking at that and realizing there's something there that wasn't really in the catalog, and he had a difficult time trying to make sense of that. It was the star Eta Carina. You can see it right here on the thing. It shows Eta, right? He picked up the nebula that it was within. And if you go back and you look at the light curve of Eta Carina, it went through a great outburst in the 1800s, really around the 1840s, right at the time that he was there working with the people. So you would have seen, it would have been a rather fairly mundane, insignificant fourth magnitude star for a long time. Then over a relatively short time grew to be extremely bright, second brightest star in the sky, brighter even than Canopus, before rapidly dropping in brightness to the point of invisibility. So this shows the time period that Stambridge was up there learning from the people. And that red line is a rough approximation of the limit of human visibility under most conditions. So Eta Carina, shed its outer layers over 20 solar masses. It shed these outer layers of this, super giant blue variable star. And when it shed those outer layers, it pulsated basically as it shed them out like a supernova impostery. It became very bright. But as those clouds, as that debris went out into space and expanded and it cooled off, it was like dust getting in the way and it blocked all the starlight. And that's why it dropped so suddenly, so rapidly over the next few decades, to the point where it wasn't even visible after a while. So we had managed to do research on this and show the Aboriginal people were talking about the great eruption of Eta Carina as it was happening. And there were other cultural traditions within the stories that gave the same indication. The idea that stellar spouses were always stars nearby in the sky of similar magnitudes. That's just the mode of how that worked. And Eta Carina would have been quite close to Canopus in the sky. They both would have been the most, second and third brightest stars in the sky. They would have been very prominent. This is the only indigenous record that we know of anywhere in the world that describes the great eruption of Eta Carina. It not only tells us that people noticed these things, but they incorporated it into their oral traditions in real time as it was happening. It also tells us something that we already know, that indigenous knowledges are dynamic. They're not static in time. New information comes in that informs those traditions, and that's a really powerful way of understanding that these oral traditions can be a pretty phenomenal record, going back thousands of years, potentially much longer than that, tens of thousands of years, potentially, of careful observations about the sky. And we can learn a lot from that. On the last bit, because we've only just got a couple more minutes, is I wanted to talk about another example of a potential supernova observation described in Aboriginal cultures of Eastern Arnhem Land. So this bark painting is telling the story of these two brothers, the fisherman brothers. These two brothers went out on a fishing expedition and out at sea, and they had been warned by elders to be careful and not really go if they could avoid it, because at the time of the year they were going out, even though it looked beautiful and clear that day, storms can appear out of seemingly nowhere. And it was a very dangerous time to be going. But the brothers decided they were going to go fishing anyway. They became so enthralled within fishing that they weren't paying attention to what was happening on the horizon. Storm clouds were gathering, and by the time the boys recognized what was happening, they could see the storms were moving in. It was becoming a very serious situation. They began paddling back to shore as fast as they could, but they weren't fast enough. The storm overtook them, the waves capsized the boat, and the older brother, being stronger and more experienced, saved his younger brother at the expense of his own life. After the storm, some community members found the younger brother lying on the shore. He was barely alive, but he was alive. And they went down, they found the broken canoe, and they asked the younger brother where his older brother was. And a little while later, they found the older brother's body. He had died, he had drowned. Now, the community, to celebrate the heroism of the older brother, because the younger brother explained to them that his elder sibling had saved him, that they decided to hold a ceremony in his honor. And the story says that a couple of days later, a bright new star appeared on the sky banks, or on the banks of the Sky River in the Milky Way. And that was the older brother telling them that he was safe with the ancestors. And later on, years later, when that younger brother grew to be an old man, he wanted to join his brother in the sky. So he asked the sky ancestors to take him up. And they became the stars Shala and Lasath and the stinger of Scorpius. So there's some interesting elements about this story. It's clearly talking about the galactic bulge. It gives you an indication of where it is in the sky. It even shows here on the bark paintings describing the story. This is very clearly the galactic bulge, right? So a bright new star appearing in the sky. Well, if the star was still there when the younger brother grew older, why didn't he join the brother in the sky where that star was? Well, he couldn't, because the star wasn't there anymore. But it does describe a good indication of the two nearest, two prominent stars that are in the tail of Scorpius, Shala and Lasath, where the older brother is the brighter star and the younger is the slightly fainter star. Now, curiously, when we begin looking at these records, we realize this is a story, and it could just be a story that's not talking about an actual witnessed event. It may just be an allegory. It may be a symbolic story, right? But curiously, when you go back and you look at supernova records over the last couple thousand years, one of them jumps out very prominently. And that's the supernova of the year 393. In the year 393, the Chinese records, the court astronomers recorded this supernova right on the banks of the Sky River. By the banks of the Sky River, what they mean is the dark spaces in the Milky Way represented the river. The banks mean it was on the edge of the bright and the dark space in the Milky Way. It occurred right in the middle of the galaxy and very close to the stars Shala and Lasath. Now, the Chinese records talk about when this supernova was visible, and it was visible at the exact time of the year that's described in the stories. Now, is that proof beyond positive that these communities observed the supernova of 393? No, it is not. But there is quite a bit of evidence on a number of different levels indicating this could be a very reliable source for that particular supernova remnant. So there are lots of examples of supernovas that have occurred throughout history that have been described in both written and oral traditions. And the written traditions, particularly those of cultures in like China and Korea and Arabia, have become an invaluable resource for astronomers who are looking for counterparts that could explain the supernova remnants they're finding that indicate very young events, things that may have occurred in the last 1,000 or 2,000 years. So by working with elders and communities, we could potentially find stories or learn about stories that describe these events appearing in the sky, telling us possibly where to point our telescopes, or vice versa. There could be supernova remnants that are discovered by astronomers, which have happened quite a bit in the last few years, that indicate the supernova would have occurred fairly recently, maybe within the last 10,000 years, and they're curious if there are any stories that describe that. So there's a lot of ways in which we're sort of bringing together these ancient written records, the ancient oral records, modern astrophysical research to see what kinds of ways that we can find interesting intersections within that world. How can they inform each other? How can we learn from that? But also, it's a bit about systems research. When you talk about how things are integrated and how things work, elders talk about a lot of exciting philosophical and ontological and epistemological frameworks that could be utilized and adapted by the astrophysics community. And these are the things that we're very, very seriously looking into right now and taking on board. So there's a huge amount of capacity for the astrophysics community to learn from and alongside elders and Indigenous astronomers around Australia. That's some very exciting research that's happening right now, and I'm really happy to be a part of that. So I'm going to go ahead and finish there. If you'd like to learn a little bit more about this, you can pick up a copy of a book I published a couple years ago called The First Astronomers. All the book royalties go to charity. I don't make any money off the book, so I don't feel guilty about flogging it, right? Co-authored with 6 elders, and it's really about the science of Indigenous knowledge. So thanks, Mark, and thanks everybody for having me on today. I really appreciate it.
You are welcome, Duane. Thank you for a very interesting talk. Got a couple of questions for you on the chat. Also, we've got that book at our library, the ASV library. I think we've got a couple of copies of it. So, Kate has a question. In Indigenous culture, there are song lines for each mob and shared song lines for meeting of the mobs at particular points. Is there any indications of shared astronomical knowledge between the mobs?
Oh, yes.
Really cool question.
Absolutely, 100%. A lot of these song lines that spread over long distances often incorporate different languages. Like when you get to the new country, you'd be singing the new language. Those song lines are mapped out in the stars, right? So one of the interesting realizations that we had learned working with elders is the elders would talk about these travel routes, traditional travel routes and traditional song lines. So if you were going to travel from point A to point B over some long distance, you had to figure out the best route to get there, right? And as you're on your journey, you got to know where to stop, to camp out, where's the food, where's the water, where's the medicine, and you need some landmarks to help you out, right? So when you figure that out and you need to teach the new generations how to do this route, how are you going to do that? You don't have a portable map. What you do is you pick earlier in the year at night, you pick stars in the sky that act as waypoints on that journey. So you kind of pick a constellation of stars that has a similar shape to the journey you're going to be taking. You create this oral map through song, and you teach the younger generations about that. And the stars serve as waypoints on your journey, and the whole thing is meant to be a mnemonic. It's meant to be a memory aid. Later on, when you're not traveling at night following the stars, second star to the right, straight on till morning kind of thing, right? You're literally traveling during the day, but you had learned it as a mnemonic aid. So what you find is that when the colonists first started going across Australia, in some cases, they'd be shown the same pathways by Aboriginal people. In some cases, they'd see these well-worn paths, whether the people told them about it or not. They'd follow the same routes, which became roads. They'd camp at the same places, which became towns. And over time, what you find is the song lines and trade routes became the network of highways and towns across Australia, which are all mapped out in the stars. And if you take the constellations of stars and scale them and put them over top of Google Maps, there's this beautiful correlation how they map out. So highway and town networks are laid out around Australia based on star maps. And you'll see that even if for anybody who might be going to Sydney, if you're going through the Blue Mountains, that main highway follows an old Seven Sister song line. But there are lots of similar traditions around Australia when it comes to astronomy. Some of that shared knowledge about that, and some of it's just describing physical things that happen in the sky, like how to read twinkling stars or what a moon halo is going to tell you. And the reason that they're so similar is because they're based on physics, and physics is the same anywhere you are.
That's a wonderful answer, Duane. I actually travelled the that Blue Mountains Highway last week, so yeah. We have another question here. Duane, are you aware of any cultures that may have used star or constellation shapes for language characters or pictographs?
That's a good question. I'm not sure. Probably. I mean, I can see lots of representations in art that describe astronomical things, and some of them were almost like a written language. So some of them would be like message sticks, and message sticks would be something you would take to somebody, you know, a neighboring community about a ceremony, and it would have depictions of the rivers where they're crossing. That's where you're going to hold the ceremony. It would tell you there'd be a figure of a human doing something. It tells you it's going to be an initiation ceremony, and it would have two moons, one moon of when the message was sent and one moon of when the event was going to happen, which would usually be separated by a few weeks. So you could see representations of astronomy in that, encoded as, you know, bringing together space and time. This is something that I teach the students in my class because the elders taught me, and it's something all of us know. You cannot separate space and time. They're completely intertwined. In Indigenous knowledge, space and time are just two sides of the same coin. Exactly the same thing we know from Einstein's relativity. Space and time are intricately interlinked. But yes, you're going to find amazing similarities across different cultures, and that's something I talk about a lot in the book.
And one last question, unless someone else throws another one at us. Is there any evidence in Indigenous astronomical knowledge of tracking repetitive comets such as Halley's comets?
Yeah, that's a good one. I don't know. I've looked at that. There seem to be some indications potentially of meteor showers that were described. I think there very well could be. I don't know of any that I can point you to, but when it comes to studying Indigenous oral traditions about stuff, it'd be like me going to Port Phillip Bay and putting a glass of water in there and being like, the glass of water is the stuff that I've been able to search so far. All right, there's tons of stuff out there. Yeah.
So it's, we know as much about that as we do about what lies beneath the ocean.
Yeah, really. But there are, there's, even though people would oftentimes describe seeing comets as omens or being surprised by them, people still knew what they were to a degree, and they recognized them. And there's lots of cultural traditions and ceremonies tied around eclipses that were predicted in advance. So that gives you some kind of indication of that. But yeah, comets, I'm not entirely sure about cycles of repetitive comets, but I wouldn't be surprised, but I don't know the answer to that.
All right, well, wonderful. Thank you very much, Duane. Oh, hang on, we have another question. Oh, we got two more questions. We're going to do the last two questions.
Try to be quick. Sorry.
All right.
Keep you too long.
No, that's okay. They don't want to listen to me give Bill's talk anyway. So, are there any stories related to SN 1054?
Supernova 1054. Probably. I mean, there's no way you're going to tell me cultures that paid very careful attention to the sky didn't notice one of the brightest supernova in history, right?
Yeah.
100% people would have seen that. That doesn't mean that I can identify a clear example of that, because like I said, I haven't had a chance to go through all the stories or anything yet. It'd be almost impossible to do. But yeah, it's a really good question. These are things we're going to be looking at more in depth over the next few years, because with these major grants come PhD students and postdocs who are going to be deep diving into all that stuff. I do want to say quickly before we finish, the petroglyph of the 1054 supernova down reported in Arizona within the ancient Anasazi, ancient Pueblo, is almost certainly not of the supernova of 1054. It is 99.99999% chance that that's referring to the crescent moon in Venus, which is a very common, very powerful motif in that area and around the world. In fact, the very first paper that talked about in an edited volume, that representing the 1054 supernova, the very next paper completely took it apart. Nobody paid attention to that second paper, but everybody grabbed the first paper and ran with it. So I just want to put that out there.
I've got last two questions. So here we go. We've got what is the next stage with your research? So where to from here?
There's so much more to do.
The world is your oyster, Duane.
So much more to do. I've got a whole team of PhD students working on various projects in this space. I've got some who are looking at microsatellites and light pollution and dark sky tourism and how that relates to Indigenous astronomy. I've got students who are working in the Torres Strait, picking up on my work where I never have time to do any work because I'm always writing grants and doing admin. I've got students who are on board working with the Kulin Nations around Melbourne. So that's a huge project we've got coming up. We're doing some major research projects between the space sector and Indigenous communities and how we can help facilitate more dialogue and engagement and reciprocal benefits between them. I've got students coming in working with communities in the South Pacific, particularly Vanuatu, New Caledonia, and the Solomon Islands. Franco-speaking student, which is good. So there's a lot of research projects happening. There's never a shortage of things to do, right, in this particular space. There's more communities to work with. There's more exciting stuff to dig into. You know, all these questions I can't answer now. I don't know if I'll ever be able to answer them, but boy, we're certainly going to try to find out.
That's half the fun of work, isn't it, in your field?
All the fun I love doing. The not fun part is doing all the admin and grant writing.
Last question, and I reckon I can answer this one. Andrew Hayes is one of our section directors, and he wants to know, he works at RMIT, and he said wants to know if he can come up and get you to sign his copy of The First Astronomers. My response to that will be, Andrew, next time that Duane and I catch up for a beer, I'll let you know, and you can come and hang out and have a beer, and Duane will sign your copy. How does that sound? That sounds pretty good. Yeah, 100%. There we go. Look, the amount of people who have loved your talk tonight, Duane, yeah, thank you very much for coming along and giving us this wonderful presentation. It's been very interesting to listen to. And it's a topic that we know is somewhat controversial, but has a lot of merit. And through your work and your students' work, more and more information is going to come to hand. That's for sure. So
there's a huge body of work. A lot of people are in this, and I can guarantee you there is no way the School of Physics, the University of Melbourne, would have me here doing this research and teaching if they didn't have a pretty damn good idea that what I'm doing is legit, right?
There you go.
Excellent. Put that out here now. All right.
Yeah.
Thanks so much, Mark.
Thank you very much for coming along, Duane. And I'll see you soon, no doubt. And yeah, I'm going to pop up Bill Stent's What's in the Sky and read through that as if I know what I'm talking about, which I don't, and share with everybody what is in the sky for. We're going to try and add that to stages. Hang on, I have to remove yours. There we go. Share that, and I'll work through that. But Duane, thank you very much for coming along tonight. I know you're a busy man, so I'm going to let you go. You can run off and you can head home now because I know you're still at work. But yeah, again, thank you very much for coming along and presenting for us.
Thanks, Mark. Appreciate it.
See you later. All right. Let us have a look at what is in the sky for April, late April, and early May. I know I am not Bill Stent, the telescope gent, and I'm definitely not the next best thing, but we will pretend that I am him in AI. Let's roll through this. Tonight, as Bill would normally say, we're meeting on the lands of the Bunurong and Wurundjeri people, or Wurrung peoples of the Kulin Nation. The general conditions at this time of year, he hasn't told me, so I'm reading straight from here. So just so you know, Bill's got COVID. He's not feeling very well. He sent me a photo of himself rugged up under blankets and said, "Can you do the talk? I've got COVID." He's going to cover off what's in the sky, where's the moon, the planets, getting orientated, suggested targets for tonight, not just for tonight, for this month and early next month. Targets for the early risers, and a little bit about the Eta Aquarids and things to look out for this month. So the general conditions at this time of year, well, there you go. He's going to tell us about them. I'm going to tell you about them. Welcome to the Eastern Standard Time. Remember, if you have a go-to mount, which most of us do, or quite a lot of us would, Don't change your hand controller time zone. Just switch back from daylight savings. That will do the trick. That's something that I'd absolutely personally had forgotten all about. And when I set my gear up tomorrow, I will be doing that. Solar transit in Melbourne is about 12:22 today rather than 1:20 last week. We're approaching winter now. We are past the equinox. And in Melbourne, it certainly feels like we are approaching winter. In fact, my car today said it was -40. Winter is more associated with galaxies, although Bill is not sure it's valid. I'm going to disagree with you, Bill. What about dew control? Oh, Bill, that photo. That is some pretty bad dew control. Hand warmer pads bought from pharmacies. Hot hands, people. Hot hands are great, not just for your dew control, but for your temperature control in cold weather as well. Hot hands have saved me through very many winter nights in freezing temperatures. You can even get the ones for your feet as well. A hairdryer if you're at home. And he is right. If you are up at the Liam, our dark sky site, do not plug a hairdryer in and try to defrost your telescope. We do not like that. Electric warming straps or dew heaters, they are your friend. Sunset tonight, which has been and gone, was at about 6 p.m. It was dark at about 7 o'clock. And next month it will be sunset at 5:25 p.m. And sunrise tomorrow morning will be at 6:40 a.m. and it'll be dark until 5:25, although most places it's cloudy, so nobody's going to be doing any astronomy tonight. Next month, it will be 7:05 a.m., Bill. A.m., not p.m. I am not even going to try and pronounce that word. For the moon lovers, I'm tipping. Full moon is on Sunday, April 13th. That is this coming Sunday, if I am not wrong. In the south over next week. So it's in the south over the next week, so it'll be high in the sky. It's right on its maximum distance, so it's a mini moon. And over the following week, it's setting in the early morning as a waning gibbous. The last quarter is on Saturday, the 21st of April. As deep in the south now, so it'll be very high in the sky, moving back over the course of the week. It rises at midnight, sets at noon. Then over the following week, it will be a waning crescent. It'll get thinner and harder to see as it approaches the sun. View in the morning now, later this week in the early afternoon, then before sunrise. The new moon is on Monday, the 28th of April, which makes the Anzac long weekend a wonderful weekend for astronomy and for the Mildura Star Party. Subtle plug. In the north, so it'll be low in the sky again, but you won't see it. Able to see it in a few days as a waxing crescent after sunset. Look west. The first quarter is on Monday, the 5th of May. Rises at noon, sets at midnight, best viewing. Then following week is a waxing gibbous. Starts in the north, but crosses the equator on the 8th. No lunar X month this month as it's below the horizon. Oh, Bill will be devastated. The planets over the next month, these are from the ASV yearbook. Watch for Mercury, Venus, Saturn, and Neptune. Let the stampede begin. Mercury, now a morning object, maximum elongation on the 22nd, rises at about 4:55 a.m. Venus is another morning object, hanging out with the party bunch. Bill, you're a funny man. Rises at 4:55, same as Mercury, but slightly further north. Mars is getting old. Let's not have age jokes, Bill. Definitely an evening object, rising well before sunset, setting around midnight. Jupiter is continuing to move ahead of Mars and sets at about 9 p.m. behind the trees for the Troughton Sims. Oh, the Troughton Sims, that's at Melbourne Observatory. It's not as good as the 12-inch Mercer, but still viewable in twilight. Just so you know, the Mercer would be able to see that at 9 p.m., unlike the Troughton Sims. A little bit of a demonstrator battle going on there. Saturn, now a morning object, just getting in twilight, rises at about 4:45. We need photos of the closed rings. We do. Anyone who's got any photos of the closed rings, let us know, please. We'd love to see them. Uranus, pretty much a daytime object now, rises about 9:45 and sets at about 7:45 p.m. Neptune, another morning object along with Venus, Mercury, and Saturn, and rises at about 5:10 a.m. Pluto, it's not a planet, Bill. Why is it in here? Now an early morning object rising at about midnight. Now we're going to be getting orientated with the sky at 10 p.m. facing south. So we have the Southern Cross at about 11 o'clock, high on in the southeast, which is there. We have Orion setting in the west, which is always good, but always bad. It's sad to lose Orion, but it also means there is another beautiful constellation rising in the east. Scorpius, which is rising in the east. Personally, it is one of my favorite constellations. There are so many amazing objects in there. Orientation of stars. We have our little clock here that Bill likes to use. Canopus leads the cross around the pole. Bacchanal is opposite the cross, low in the south-southwest. Sirius is bright and getting low in the west. Castor and Pollux are low in the northwest near Mars. It's quite a good view looking at those three in the night sky at the moment. Regulus is just past the meridian in the north. Speaker, I get told different names for that one. I'm going with Spiker, is getting high in the east-northeast. And new this month, Arcturus is low in the northeast. Antares in Scorpius is low in the east-southeast. Do love Antares, it's beautiful. Planets, Mars is low in the northwest. That's right near Castor and Pollux. Jupiter is setting at around 9 p.m., so she be gone. Goodbye, Jupiter, for the time being. Bill's visual targets for the evening. Sky at 10 p.m. facing south. Jupiter, last chance. Very, very much so. Mars, double time in a few multiples. Okay, so we're going for Acrux, double star. Alpha Centauri. Sirius, difficult companion lost in the glare. Castor, a very low. Southern Albiro, he does like putting this one in. It is one of his favorites. It's a color double. Regor, Gamma Velorum, Delta Corvi, Beta Monocerotis. I will get that one right one day. It's actually a triple. Beta Scorpii and Beta Tucanae, which is low and very difficult if you're in a built-up area, that's for sure. Zeta Reticuli. Bill, did I say that one right? It's a bit higher. Apparently, you got to watch out for aliens. I'm not sure why. He would have had a story for that, but I don't. So, photographic targets. These have come from Facebook. Sombrero Galaxy. It's a good target at the moment. Anne-Marie, that is a lovely image. Statue of Liberty has been a good one for a while now. And Gerald, that is one of the best Statue of Liberty images I have seen. We have the Dark Doodad. I do love the name of that one. Sam, as always, a great astrophotography. Southern Pinwheel, which was taken from the ASV's remote dome. The NGC 2997, which was taken by Mike Sidonio, Strongman Mike. Markarian's Chain from Rick Zhang. Herschel's Ray, Jacob Heppel. Centaurus A from the ASV remote dome. And Vesta Opposition is the 2nd of May. How about an image? No one's got an image. That's why he's put that on there. If you've got it, we'll skip back, actually. If you've got an image of Vesta, share it with us. Sky at 5 a.m. facing south. The Southern Cross is now well past the meridian, 2:30 from the south celestial pole. And there it is there. Scorpius is just past the meridian at 5 a.m. The galactic core is close to the zenith. The planets, Venus is rising. Mercury rising. Jupiter Ascending is the movie. Saturn and Neptune are all rising. Oh, Bill. T Corona Borealis. Bill, it hasn't done anything for a long time, and I doubt it's going to do anything for a lot longer. But still, he persists in putting it in here. If anyone else can get some photos of T Corona Borealis for Bill, that would be great. We have sky at 5:45 a.m. tomorrow facing east. We have sunrise at 6:42. About a half hour after this, we have naked Saturn, bright Venus, Mercury, Neptune under the marker. So quite a lot of stuff going on there at the moment. The Eta Acarids, good this year with a favourable moon. The meteor shower is active from the 19th of April to the 28th of May. Dust from the tail of Halley's Comet and peaks on about the 6th of May. Plus or minus a couple of weeks, the moon sets at 12:40 on the 6th of May. At a dark sky site, it could be up to 40 per hour and look generally east after about 3 a.m. Go to LMDSS on Saturday, the 4th of May. Warm clothes, blankets, and a banana lounge. If you are an ASV member and you want to see something like this, the dark sky site is probably the best place to go. Final notes, random observations. At 22nd of April, Mercury is its greatest elongation, good morning viewing. On the 28th of April, Venus is at its brightest with morning viewing. 2nd of May, Vesta opposition Mag 5.4. 4th of May, best date for viewing the Eta Acarids from the Leon Mao dark sky site. 6th of May, Pluto stationary retrograde starts. The astrologers are going to be out in force from the 6th of May. There it is there. And then it's coming back. Oh my gosh, Bill, you have done a lot of work. 6th of May, Eta Acarids meteor shower peaks look broadly east early morning. On the 10th of May, the moon and Spica east just after sunset, less than a moon diameter away, so nice and close. 15th of May, Juno opposition, Mag 10.2, so much less bright. T Corona Borealis, keep watching for a sudden bright star. Rises at 8:30, transits at about 1 a.m., sets at 5:45, so all night, but low. Bill, you will need to move on to another object soon because T Corona ain't doing nothing, buddy. Sources, Bill has put his sources in there and he thanks all of the ASV contributors, even though they don't know that they're going to be contributing. He just grabs them off there. And that is our lovely talk. I'll add myself back. I hope that worked. Where are we? I've lost control of my own screen. There we go. There we go. So hopefully that makes some sense. And we all got to see Bill's lovely talk of the night sky, tour of the night sky. And thank you again to Duane for coming along to present tonight. It was greatly appreciated. He's done a great job, and he always does a great job. So again, thank you to Duane. Thank you to Bill for providing me with that presentation. And we will break that up into a What's in the Sky video that we will upload separately as well. Thank you everyone for coming along tonight, and hopefully next month we will see you in person as well as online from Mueller Hall. But for now, we will see you next time.